morning, everyone. Can you hear me? Hopefully you can. Excellent. So I'm going to talk to you about millimeter wave and our deployment in Australia. Hopefully I'll persuade you that it's actually worth looking to millimeter wave. I think Brian made a comment earlier. I just noted it. He said, millimeter wave is not magic. And then you proceeded to talk about what you've done in stadiums. Hopefully I'll persuade you that actually it is almost magical. And I hope that it's going to be an interesting presentation. Let me start with a little bit of history. My name is Iskra Nikolova. I'm responsible for the network infrastructure in Australia. And this includes for Telstra, and this includes radio access network, fixed access network, transport and IP, and all the other infrastructure, including cloud. Obviously, in the radio access network, we are the market leader. We've got the biggest and the fastest mobile network in Australia today. It has by far the most sites. It does cover 80% of the population, just under 80% of the population today. And the main band which we have rolled out is mid-band. So the network is built around mid-band. We also have low band, a combination of 700 megahertz, 850 megahertz as well. In millimeter wave, we have significant bandwidth. We have a full gig, 1,000 megahertz millimeter wave, and we have started experimenting with millimeter wave some time ago. So do I move the slides with this? Perfect. So we've started in 2016. We've launched the first testbed in Australia, and we started with trials. Initially in our 5G Innovation Center, so 2017, but we moved out to roll out quite quickly in 2018. At the time, there wasn't necessarily mature equipment. The first millimeter wave device, and that was a data device from ZTE, was launched in 2020. And here we are in 2021. There was a spectrum auction, and this is where we got 1 gig spectrum. And more recently, we have now the first millimeter wave device, which is Google Pixel in the country. One of the challenges has been how fast device vendors will make millimeter wave devices available. And we are now seeing some movement, so devices are available. So we have a long history in millimeter wave. We have been very public with our strategy to densify the network with small cells based on millimeter wave. And one of the engineering challenges for the team has been, okay, if we are going to roll out millimeter wave network, how are we going to load it with traffic, given the propagation characteristics and also the cost base? So what we started doing, first of all, we started with a strong statement of intent, which is millimeter wave for us will be a valuable addition to the 5G macro network. And we are going to densify the network with millimeter sites, not just in high traffic areas such as stadiums. We are not seeing it just as capacity augmentation. We are seeing it as a valuable network, specifically in CBD areas, in metro areas. In order to do that, we had to do 2 things. We had to extend the coverage, and we had to lower the cost base. And what we found is that by using specifically repeaters, we can effectively extend the coverage of a small cell, and also in terms of bandwidth, cost per bandwidth, we can lower the cost as well. Now, the market of repeaters, when you look at all the mainstream vendors, they don't necessarily have repeaters. It's almost, I'm not sure if there are any people in this audience from Ericsson or Nokia, but the portfolio is not as rich in terms of repeaters, specifically for millimeter wave. However, there are startups which are developing repeaters, and they're working pretty well. And I think they've been piloted in North America. I think Verizon has been probably experimenting with them. We have experimented as well, and we now know that using repeaters, we can extend the coverage, we can load the traffic, and small cells using millimeter wave become a absolutely viable option in terms of how we augment and how we densify the network. So as we continue, we had to work with the ecosystem. We had to work with the vendors And in our case, we are using Ericsson, so it's all Ericsson network in Australia for Telstra. to really also shrink the size of the radius to make them mountable on small cells. So there were quite a few parameters that had to come together. But we've been very clear with our strategy that we will go and densify the network with millimeter waves, and that had the pulling effect on everyone else to come and work with us. So in terms of our 2025 ambitions, now Telstra has been executing a very clear strategy. We call it T22, which has been a strategy of a turnaround until the current year. We have achieved great things. We have taken a lot of cost out of our business. We have doubled the share price. We have simplified our operations, significant progress. Our next journey is what we call T25, our next 5 years or 4 years in our next strategic ambition. And this is a strategy of growth. That's how we describe it. We are going to maintain and expand our 5G leadership. And as part of that, we have committed that we will roll out 5G to 95% of the population of Australia by 2025. Now, if you can imagine the topology of Australia, you can then begin to comprehend how ambitious 95% 5G is. So far, it has truly transformed, how people consume bandwidth on mobile devices in the country. And obviously, millimeter wave is a significant part of it. I tend to talk about contiguous coverage on small cells in millimeter wave in CBD areas, in cities like Melbourne and Sydney. It's almost like a different way of thinking about what you can achieve with millimeter wave. Previously, if you work in radio planning, you were using small cells to augment capacity in stadiums, in special events, etc. We believe there is another way. And as long as devices are available, users can benefit from ultra-high speeds. So we just announced here at Mobile World Congress a new record for peak speed using millimeter wave and Netgear device, 5.9 gigabit per second. We also see very high uplink speeds. Some time ago, just a few months ago, we announced another world first it was, I think, uplink up to 1 gig. That one was on SA, but it cannot be achieved without millimeter wave. So if I move forward, I want to talk to you about one case study just to show you that what we can do with millimeter wave is has significant impact both in cities but also in stadiums. And of course, stadiums like this is Melbourne Cricket Ground. It is the biggest stadium in the Southern Hemisphere. It's the 11th biggest stadium in the world. It has 100,000 seater capacity. And it was impossible to provide the quality of customer experience on this stadium without millimeter wave. So we have deployed millimeter wave small cells, and today users, and I can tell you this is really a very popular venue in Melbourne for all the cricket lovers there. The users can benefit with millimeter wave devices of speeds of 2 to 3 gigabit per second download speed. So that kind of experience is unmatched. It cannot be matched by mid-band or any other spectrum. And clearly, millimeter wave is the way to go. It has been quite complex to engineer, but obviously we've done it, and we are very proud of the results. So what next for millimeter wave? We believe it's a growing market opportunity. As we have been talking to our vendors, they're coming on the bandwagon, and they do have roadmaps for millimeter wave products. It's not just any products. What we need from them is small form factor, power efficiency, because obviously we're talking about small cells. We have to be able to mount them anywhere. And also, we should be able to integrate them with repeaters in order to extend the coverage. When we talk about millimeter wave networks, the question is, can you build it? Can you load it with traffic? Because obviously, we don't really want it to be brand new and shiny, but not loaded. We are also thinking about a couple of other things. So increasing the hardware capacity, so what kind of capacity we can support, but also increasing the coverage on millimeter wave. So we are now beginning to see extended coverage. So previously, initially, we were thinking, okay, the coverage will be up to 1 kilometer. Now we can see extended coverage together with repeaters, together with fine-tuning. We can definitely achieve more than 3 to 4 to 5 kilometers. In dense city areas, such as central business district, that is absolutely adequate for us to achieve contiguous coverage. And that kind of statement of intent then leads the ecosystem further, because what device vendors want, they want contiguous experience on their device. And therefore, as we build the network with this in mind, we have a chance to pull the rest of the ecosystem with us. So in conclusion, in terms of taking this forward, we have to work together. We have to come together as an industry, and this is where the GSMA is playing a wonderful role, and we are very grateful for being invited here today to talk to you about mmWave. We have to work together because a number of components of the puzzle have to come together, whether it's devices, the equipment, the form factor, the energy efficiency, the extension of the coverage, and most importantly, the cost base as well. And cost effectiveness is hugely important. So how those small cells are going to be rolled out. What we've done in our network, we have done zero-touch provisioning. So the provisioning is automated 100%, and that allows us to roll them out quite fast and in bigger quantities. We are also seeing increasing software capabilities. So, that kind of programmability of the network is critical when we're talking about small cells. And then eliminating the manual component, which effectively drives the cost down. The true value of 5G, in my view, will be unleashed with mmWave. We as operators were very busy in the first couple of years of 5G, really powering up everything with new radio. And obviously, we started with NSA, with non-standalone architecture. Now, I don't think this is a true 5G, right? In 10 years from now, when we have ultra-high speeds enabled by mmWave, when we have standalone architecture being the prevalent architecture everywhere, we will then see the true power of 5G. Now, we've been tempted to go with the low-hanging fruits, to reuse existing infrastructure such as NSA, for sure. But most certainly, I believe that by 2025, the 5G networks of the future will be different from what we see today. And we hope that Telstra will be leading the way. The ecosystem point is critical. So it does require a little bit of kind of statement of intent, because it is volume game. It is a volume game in terms of factories, from vendors' point of view. It's a volume game in terms of devices as well. So we kind of need to work together, and hopefully we will create this momentum. With this, thank you very much.
Thank you very much, Iskra. Next, I'd like to invite Shen, Senior Solution Architect from ZTE, to come and talk to us further. Thank you.
Hi, good morning, ladies and gentlemen. Welcome to 5G mmWave Summit. And my name is Shen Yang, and I'm from ZTE Corporation. Today, I would like to take this opportunity to introduce ZTE's exploration and application in mmWave industry. We know that mmWave has some unique features, such as a rich frequency spectrum, and also it has some disadvantages and challenges, such as high penetration loss, poor diffraction capability, severe attenuation. But according to GSA statistics, until the December of last year, there were totally 192 operator investments in 48 countries. This shows that mmWave is developing very fast. Based on the ZTE experience, we have explored mmWave in the 4 directions and application scenarios. First, fixed wireless access. Second, wireless backhaul. Third, 2B area, and finally, the 2C area. In the future slides, we will see these scenarios and cases one by one. FastWeb case has been introduced and mentioned by the previous speakers for several times. And actually, this case is is helped by ZTE Corporation. And let's see the FastWeb situation first. FastWeb has a 200 megahertz millimeter wave spectrum, but it only has a millimeter wave spectrum. They do not have 4G spectrum. But this network is purely built on the NSA non-standalone architecture. So how can we achieve the network architecture? In Italy, we cooperated with another operator, Lincoln, to get the NSA network architecture down. Lincoln's LT services and carrier is used for the two functions. The first function is used for its LT service. The second function is used for the FastWeb, used as a NSA anchor point. By this way, we built a complete NSA network for FastWeb. Now this commercial case is running now in Italy. The second scenario I would like to introduce is a wireless backhaul. Here, the millimeter wave base station can be used as a donor base station or relay base station. Anyway, the relay gateway and the core network is necessary to support the whole network architecture. The table below shows the performance that we can achieve by the different distances. If we have a 400 megahertz bandwidth and a 26 dBm CPE, we can achieve 80.8 uplink capacity at 5 kilometers and 578.5 Mbps for downlink capacity. This is what we can achieve now. And we have planned more far distance, and we will plan 10 kilometers for this year. Since years ago, ZTE has explored application in the vertical industry, and we have many cases. Here, I would like to give you two examples. The first is what we have built in China, Binjiang factory located in Nanjing city, which is a very beautiful city in eastern China. In this factory, take a workshop as an example. We have two types of uplink requirements. The first requirement is a 360-degree camera. The second uplink requirement is a high-definition camera. Each workshop needs one 360-degree camera and a 10 high-definition camera for AI quality inspection. If we combine all these two types of uplink requirements together, we need around 2.5 gigabps for uplink. Sub-6 gigahertz cannot handle such uplink bandwidth requirement. Only millimeter wave can do this. This is the first case. The second case is the port. In China, we have many ports in China. Take a typical port. For example, we have a 20 crane bridge. There are several data requirements, including the video monitoring, SDI video, and the PLC remote control. And we combine all these uplink requirements together. It needs 2.3 gigabps. The same as the first case. It cannot be handled by sub-6 gigahertz. Only millimeter wave can help handle such large bandwidths. And here, later, I will mention another important feature provided by ZTE, 1D3U technology. One downlink, 3 uplink frame structure can help resolve this super large uplink data requirement. For the 2C scenario, I think that we are all familiar with this, as speakers has mentioned before many times. This is a cases we are focusing on now. We have a two application case, outdoor hotspot and indoor high capacity. Since a year ago, ZTE has made a verification on this area. For example, in 2018, we have made 4K HD video based on SA architecture, standalone architecture. And in last year, we have made 920 megabps uplink rate and finished successful 8K HD video demo based on the world's first millimeter wave 1D3U technology. Previously, I have introduced 4 application scenarios. Later, I will discuss 3 challenges that we are facing with mmWave. The first challenge is that how can we be adaptive for the different scenarios? We have a different requirements. I provide 3 options here. The first option is the super large uplink requirement. In this case, we need the frame structure for 3D 1U, 3 downlink and 1 uplink. The second option requests for the super uplink data requirement. In this case, we request for 1 downlink and 3 uplink. And the third option, we have a balanced uplink requirement and a downlink requirement, which requests for the 2 downlink frame structure and the 2 uplink structure. So how can we be balanced between all these 3 options? ZTE has a innovative solution which is named DFS, Dynamic Frame Structure, to be perfectly handle this challenge. The second challenge we are facing with is how can we keep the performance under the different network architecture, including the NSA and SA. Now we have supported all these 2 architecture for insurance of millimeter performance. Even in SA network architecture, we can support NRDC, NRCA, and FR2 only. Here is the test and the demo we have made. You can see the results in the slide. The third challenge, and I think that we know this, it's obvious for the millimeter wave coverage. Coverage is a very issue for the millimeter wave, and ZTE has now developed a product named RIS, Reconfigurable Intelligent Meta Service, to handle this and face with challenge. RIS is based on a new material. It can reflect the signal to improve the millimeter wave coverage. If you have chance to visit ZTE booth this year in MWC, you can see this lovely product. And last year, we have made a demo and a test in Shanghai R&D Center. Based on this test, we have achieved 35 dB increasement regarding RCFP and 35 dB increasement regarding CNA, and 50 times improvement in terms of the throughput. Finally, I will say that until now, the millimeter wave are recognized by the industry step by step. It has unique advantages along with some challenges. But I believe that with our cooperation, the millimeter wave will play a more better and a more big important role in the future. Thank you. That's all my speech. Thank you.
Thank you very much, Yang. Next, we have Michael Thelander, President and Founder of Signals Research Group.
So first of all, you can tell that's my pre-COVID picture right there when I actually had more hair. I've since taken to cutting my own hair because of COVID. So what I would like to do today is talk about a benchmark study that we did that really looked at 5G millimeter wave performance in the real world. So we actually did testing in 2 different venues. And you heard Brian from Verizon talk about what's happening in Phoenix at the Phoenix Suns Performance Center. This is actually testing we did where they actually play basketball. So this is the Footprint Center. It's in downtown Phoenix. And it's not only about the Phoenix Suns. So the day we got there, the night before, the Eagles played. So they had 2 nights of a rock concert. You know, the venue's packed with people. That following week, Disney on Ice was coming. So the whole time we were there testing, the place was freezing, but they were actually setting up, freezing the floor, putting water on it and freezing it so, Mickey Mouse and everybody else could go skating on it. So the testing we did there was actually in just one small isolated area, really looking at, let's load the network up on LTE, look at the incremental benefits of 5G. So that's a refreshment center. And that's where you go to get your beer during the basketball game, or if you're there for Disney on Ice. So it's a really high congested area. What are the incremental benefits of 5G millimeter wave in an environment like that? The second part of the study, which I thought was actually more interesting, and that's because we did testing in Europe. Now, everybody thinks about, well, millimeter wave, that's Verizon Wireless, that's the United States. Well, that's really no longer the case. So this is testing that we did in an outdoor area in Elisa's network in downtown Helsinki. It's an outdoor market square. It's outside of a shopping mall. People go there every day to buy their stuff. So it's a high traffic area. Again, what are the incremental benefits of millimeter wave? And more importantly, you see an FR1 band N78 radio there. So this is an operator. Not only do they have LTE, they got mid-band, and on top of that, they've got some deployments of millimeter wave. So I'm really going to answer 3 questions today. How does it perform, first of all? Second of all, why do operators with mid-band spectrum actually need millimeter wave? And then finally, why do consumers need access to gigabit per second data speeds? And I'll tell you right now, they don't. And that's probably one of those statements that will come back to haunt me in 5, 6, 7 years. But at least in the here and now, there's not a single application out there that needs gigabit per second speeds to a single user. But that doesn't mean that you don't need 5G millimeter wave. So this is testing we did in downtown Helsinki, and I'm going to highlight things very quickly, but you can see the market square. You see the pin right there. That's where there was LTE, there was FR1, and there was millimeter wave deployed there. So this is a walk test that we did. We did it first of all for LTE, looking at the 3 bands the operator has there. Then we did the same walk test with FR1, and then finally we repeated it with millimeter wave. And so what you see there are the colors. Those are the colors that identify each 5G or LTE radio. So in this case, on the left-hand side, that's band N78. The purple, that turned out to be the area of interest. That was the 5G radio broadcasting in that area. You see the other colors? Those represent, again, there's coverage there. That just so happens to be coming from another 5G radio. And then finally, on the right-hand side there, that's millimeter wave. So there's a couple of points I want to make here on this slide. Again, this is really looking at coverage. And again, on top of this, we're looking at what's the total capacity that we can get in this area. So first of all, and it's not quite clear here or not, but the LTE coverage is actually comparable to the mid-band 5G coverage. And you can say, well, why is that the case? It's a much higher signal, less propagation, et cetera. Well, the answer is this is a very dense network. So yes, if you go out in the middle of nowhere and you try to see how far a signal goes, you're going to see propagation differences. But in a high traffic area where an operator deploys mid-band, where they deploy millimeter wave, coverage becomes less of a problem. Now, perhaps there are some areas there where you go inside a building, you may not have the mid-band coverage, but at least from an outdoor perspective, the coverage is identical. And then second of all, on the right-hand side, if you look at the far right side there, you see along the street there, that is all of that whole color there, that is all coming from that same 5G millimeter wave site. And what's interesting, I'm going to walk over here. So you can see we actually have coverage right along here. You look back over here, yes, there's mid-band coverage, but that's coming from a different 5G radio. So for some reason, millimeter wave actually has more coverage from that site than mid-band. The other interesting thing is, you can't see it here, but there's actually buildings between me and that 5G site, but yet I'm getting a signal. Well, how can that be? Well, I would argue it's probably coming off of reflections off of that right-hand side. Now, I'm not going to say that that was actually a good signal, a strong signal, but at least we had a 5G millimeter wave connection, most likely coming from reflections. So we've all seen the capacity layer chart, or the cake, if you will, going back to the days of 3G. What's interesting here is that this is 4G and 5G, and more importantly, this is drawn to scale. So what we see here is the capacity density that we're getting in that earlier slide in that area where we did the testing. So down below we see LTE, the blue. That's the coverage layer, if you will. The green is the kind of the mid-band capacity. You'll see, first of all, that you get more capacity. It's a bigger slice, if you will, a thicker layer of the cake. And then finally, millimeter wave on top of that. Now, if you really care about the math, you go to the right-hand side. And so what you see here is that if you go from LTE to 5G millimeter wave, there's about a 10x increase in capacity that you get. Now, yes, there's that interim level there where you get some capacity gains, with the mid-band, but the key thing there is, go back to what Peter spoke about this morning here, talking about the growth in data traffic. He said there's going to be roughly a 5x increase in capacity between now and I think 2027. He didn't say, well, it's going to go to a 2x increase and then plateau and flatten out. So yes, mid-band does get you somewhere for the next couple of years, but ultimately an operator is going to start to run out of capacity. And when they do so, that's where 5G millimeter wave kicks in. I'm going to switch gears now, go back to the United States, go back to Phoenix and the Footprint Center. So again, this is testing that we did by the refreshment center. We had, in this case, we had 16 phones all doing LTE data traffic, all being served by the same LTE radio. And then we would bring up phones on 5G and really look at what additional capacity do we get, what's the impact on the user experience. So on the left-hand side, this is roughly, I believe, 55, 60 megahertz of LTE spectrum. What we're showing here is how much capacity in megabits per second are we getting in each frequency band. The thicker the layer, that means more capacity, obviously. So in total, we're getting about 350 megabits per second of total capacity. That sounds like a lot, and it's actually pretty good for LTE given the amount of spectrum. But keep in mind also, this was an empty venue. We're only loading one sector. That means there's no interference. So if there was a rock concert going on, there's a lot of interference going on, that is going to come down. So that's, in a way, somewhat unrealistic. What we're plotting on the right-hand side here, so this is looking at how much user data speeds is each mobile device getting. So you can see in this case, for this test, we had 16 mobile devices. In the blue, we're plotting, well, what is the downlink data speed that that mobile device is getting? In this case, we turned on 4 phones to 5G millimeter wave. Again, it's 800 megahertz of spectrum. You can see there's in this case, about an 18x increase in data speeds, which is really good. But more importantly, you can look at, just despite the fact that there's a lot of bandwidth there, and it's 3 carrier aggregation with LTE, the actual data speeds aren't that high because, again, it's a capacity-constrained environment. So why does that matter? Well, we'll see that on the next slide. I'm sorry, this is the uplink. I have one more slide before I get there. So this is doing the same thing. It's looking at it from an uplink perspective. So again, left-hand side, that's looking at the total uplink capacity that we get. It's roughly 170 megabits per second across that 60 megahertz of spectrum. On the right-hand side, again, we have those 4 mobile devices. In this case, we've turned on millimeter wave. You see, again, a dramatic increase in the data speeds that those UEs are getting compared to what you get on LTE. So why does that matter? What's the user experience? And again, I said, high data speeds don't matter. So this is one application that people like to do when they go to a concert, they go to a basketball game. They want to stream. They want to say, I was here, look at what I did. So this is an example of what you get with YouTube Live, streaming from an event. On the top here, you see basically, well, what was the video quality? Left-hand side, that was my original source video. It says, this is what I should see. Next one over, well, that's LTE in a congested network. Not very good. Right-hand side, well, that's what happens when you have a congested LTE network and you turn on 5G millimeter wave. You can look at it from a different perspective down below. This is, again, looking at kind of the frame rate, looking at impairments in the video. You see a degraded performance. This application is not generating gigabit per second data speeds. It was generating 12 megabits per second in the uplink. I couldn't do that in an LTE congested network. I turned on 5G millimeter wave. I was only getting 12 megabits per second, but that's all I needed. That's all I wanted. I couldn't get it on LTE. I could get it on 5G millimeter wave. So again, I said we had published a study. Definitely there's 60 pages there. I covered about 1/10 of it, if that, in 10 minutes. I would highly encourage you to go ahead and download that paper. It's available on our website. I think it's out there on the web as well under my LinkedIn profile, but definitely a lot of good information there. I encourage you to take a look at it. With that, thank you very much.
Thank you very much, Michael. Our next speaker, Marco Arioli from FastWeb, the CTO of FastWeb, is not able to be here in person, but we'll see a video of him speaking to us from Milan in Italy, I think. And further to that, Henry Calvert, my GSMA colleague, head of networks, will close the session. Thank you very much.
Hello to everyone, it's Marco Arioli speaking. I'm Technology Officer at FastWeb. First of all, I would like to thank you for the opportunity to take part at this summit, and I think that the topic that we are discussing today is one of the most exciting and strategic topics. FastWeb is one of the largest operators in Italy with 2.8 million wireline customers and 2.5 million mobile customers. Since the beginning in 1999, our DNA has been focused on innovation and infrastructure. We started in Milan, the second largest city in Italy, to deploy FTTH connectivity for providing high quality and high performing services to our consumer and businesses customers. Since the beginning, our DNA has been focused on innovation, and our goal is to provide and to connect businesses, family, enterprises, promoting the digital transformation for a connected, inclusive, and sustainable future for everyone. As the 5G technologies came, we thought since the beginning that that was one of the strategic technologies to leverage on in order to continue to provide such quality and high-performing services to our customers. So in 2018, we have got 200 megahertz 5G spectrum at 26 gigahertz. And as soon as we've got our block, we started to test it and to test the new technologies in our labs. We've got since the beginning very incredible performances that were fiber-like performances, I have to say. So we were providing connectivity over 500 meters up to 800, 900 megabit per second, so fiber-like performances. And that's the reason why we thought and we started to roll out a wide 5G FWA network with the goal to cover 12 million households and businesses in order to close the speed gap that in Italy we still have. And we know, since the experience we have got in the last 2 years, how it's crucial to have a very high-performing and high-quality connectivity, both for consumers, but also for businesses and public administration. Our approach to 5G FWA service is to provide the customers with an external antenna and connecting over line of sight the receiving antenna at the customer premise to the base station. And the results that we are getting from the field are very outstanding, as we are getting an average download speed performance of about 650 megabit per second. So we have got and we are reaching such results thanks to the intense work we have done internally, but also with our team, but also with our partner like Qualcomm that is providing and supporting us with the technologies on CPE side. We think that in the future we still have to continue to work. We have done a lot of work, but a lot of work has to be done in order to integrate all the features and all the capability that are needed to continue to provide the success of millimeter wave. I'm referring to features like FR2 SA support and Ethernet PDU that are key for providing the new services that the customers are asking for. And also we have to work on the coverage side, leveraging the high power CPE in order to increase the coverage capability, but also the stability of the lines. We are so excited to continue to work on that space because it's a very promising technologies and promising space. And I would like to thank you again for this opportunity. Bye.
Good morning, everyone. My name is Henry Calvert. I'm a head of networks at the GSMA. And in closing this summit today, I'd like to bring a little bit of a sense of urgency to 5G millimeter wave and what it can bring to us. The momentum 5G has brought is the fastest ever generation of technology introduction we have ever seen. By the end of 2022, 1 billion connected 5G devices are going to be present around the world. We're forecasting that by 2025, that will reach 2.15 billion connected customers. That's a fifth of all connected customers by smartphones in the world. And the pace that this is actually happening surpasses 3G and 4G. And we're living in the gig economy. And unfortunately, Michael sort of has hit my little speech here, because he was actually saying we don't need a gigabits per second connectivity. But operators like to sell low latency gigabits connectivity. And in that gig economy, that's gigabytes of consumption, not in a month, but in a day. And in 2019 at WRC, they allocated gigahertz of spectrum in the mmWave band. And we have to think about how to not only use that, but actually, because we've seen so many use cases and so many viable reasons why technically this makes sense. But the performance and a lifestyle that your customers and consumers are using expects the customer experience of a very reliable connection. So I implored that we focus on 5G mmWave as the next toolkit that we can actually deliver the next wave of 5G era use cases that we've seen today. I'd like to thank all the speakers that we have had today, the partnerships that we've brought together, the way that they have collaborated in less than 3 months to bring this information to bear, because they feel it is now that we need to act on 5G mmWave. So thank you very much, and I'll close the summit. Just a little bit of promotion. Another use case for access would be the Open RAN Summit, and we could actually take mmWave discussions to them and get some products for 5G mmWave. So I hope to see you today at 2:30 to 5:30 in the same room. Thank you. Bye.